Right now, something is pulling our galaxy through space at hundreds of kilometers per second. We are moving toward it faster than you can imagine, and we cannot see what it is. That is the number one mystery on this list, and scientists genuinely don't know what it is. But before we get there, there are four other things in the sky that refuse to be explained. A star that dims like something is passing in front of it. A cold wound in the oldest light in the universe. A visitor from another star that sped up for no clear reason. These are five space mysteries scientists still can't explain. We start at number 5. Number 5, the repeating fast radio bursts. Somewhere in deep space, a signal fires. It lasts about 1,000th of a second. In that instant, it releases as much energy as the sun gives off in days. Then it is gone. These are called fast radio bursts, and radio telescopes have caught many of them. Most flash once and are never heard again, but some repeat. They fire again and again from the same point in the sky. And at least one of them repeats on a regular cycle, switching on and off in a steady rhythm. That is what makes them strange. A single random flash could be almost anything. A rhythm suggests something is driving it. The leading explanation is a magnetar. A magnetar is the collapsed core of a dead star with a magnetic field so intense it warps the space around it. Such an object could, in theory, whip out these bursts. That is the best current idea. It is not the confirmed answer. Scientists still don't know exactly what produces every one of these bursts, or why some keep a beat. Something out there is shouting in millisecond pulses, and we are still learning to read it. Number 4. Tabby's star. Its catalogue name is KIC 846852. It is a star a little larger and hotter than our Sun, over 1,000 light-years away. Telescopes watch stars like this to measure their brightness. A normal star stays steady or dims in a smooth, predictable rhythm when a planet crosses in front of it. Tabby's star does neither. Its light drops suddenly, sometimes by a few percent, sometimes by as much as 22%. That is an enormous dip. A planet the size of Jupiter would only block about 1%, and the dips come in no clear pattern. Something large and irregular is blocking the light. When this was first noticed, one idea caught the world's attention. Perhaps an alien civilization had built a giant structure around the star to harvest its energy. That hypothesis became famous, but the evidence has not supported it. When astronomers studied how the star dimmed, different colors of light were blocked by different amounts. A solid metal structure would block all colors equally. Fine dust would not. So the leading explanation is dust, vast, uneven clouds of it drifting around the star. That fits the data far better than any megastructure. Still, scientists don't fully know where such strange, patchy dust came from, or why this one star behaves so unlike its neighbors. Number 3, the CMB Cold Spot. To understand it, you have to look at the oldest light there is. About 380,000 years after the Big Bang, the universe cooled enough for light to travel freely. That first light is still around us today, stretched into a faint glow called the cosmic microwave background. We can map it across the entire sky. It is remarkably even, with tiny hot and cold ripples scattered through it. Those ripples match what our models predict, except in one place. In one region sits a cold spot far larger and colder than the models comfortably allow. It is a vast patch of the early universe that is simply too cold. The leading explanation is a supervoid. A supervoid would be an enormous region of space with far fewer galaxies than normal, and light passing through it could lose a little energy and appear cooler. Astronomers have found evidence of an underdense region in roughly that direction. But here is the honest part. The measured void may not be empty enough to fully explain how cold the spot is, so scientists don't know for certain what created it, a flaw in the oldest picture of the cosmos, and we can't yet say why it is there. Number 2. Oumuamua. In 2017, telescopes spotted an object moving through our solar system. It was not orbiting the Sun. It had come from another star, then passed through, and was leaving again. It was the first confirmed interstellar object we had ever seen. And it was odd. As it tumbled through space, its brightness swung wildly. That suggested a very elongated shape, far longer than it was wide, unlike any comet or asteroid we know. Then came the strangest part. As it left, it sped up slightly, more than the sun's gravity alone could account for. Something gave it a tiny extra push. Let me be clear about what this almost certainly is. It is a natural object. The competing explanations are all natural ones. It may have been venting gases like a comet, giving it a gentle shove, even if we didn't see an obvious tail. Or it may have been a fragment of frozen material that released its own kind of gas as sunlight warmed it. These natural ideas fit what we observed, but scientists don't know for sure which one is right. And here is the eerie part. Oumuamua is already gone, racing back into interstellar space forever. We will never observe it again, whatever answer exists left with it. Number 1. The Great Attractor. This is the one that should unsettle you the most because it involves us. Our galaxy is not sitting still. The whole Milky Way is moving through space at hundreds of kilometers per second. And it is not alone. Thousands of galaxies around us are being pulled in the same direction, toward the same point in the sky. Something is drawing an entire region of the universe toward it. Astronomers call that something the Great Attractor. The leading explanation is a colossal concentration of mass, a dense collection of galaxies and dark matter with enough gravity to tug on all of us. That much we can infer from the motion. But there is a problem. The Great Attractor lies almost exactly behind the crowded plane of our own galaxy. The dust and stars of the Milky Way block our view of it. Astronomers call that region the zone of avoidance because it is so hard to see through. So we can measure the pull, but we cannot fully see the source. Scientists don't know precisely how much mass is there, or everything that hides behind the veil of our own galaxy. And that leaves us with a quiet, honest fact. We are being carried across the universe towards something. We can feel its gravity in the motion of thousands of galaxies. We just cannot see what it is. These 5 mysteries are not stories someone invented to frighten you. They are real observations, sitting in real data, waiting for answers we don't yet have. A signal that keeps time in the dark. A star that dims like something is there. A cold wound in the first light, a visitor that pushed itself away, and a pull we are all following without knowing its face. The universe is not fully explained, and somewhere out there, quietly, it is still keeping its secrets.